3-2 is graphing linear equations in two variables. Okay, in two variables. So today what we're going to do is we're going to take a look simply as two variables, then we're going to look in the form x equals h or y equals k. Okay, we're going to talk about something called an intersection as well. An intersection. How many people, just by a show of hands, have seen some form of graphing lines, even if it's a minimal amount of graphing lines? Okay, thank you. All right, so let's take a look at example 1. We're going to start our first technique as graphing by plotting points. I am assuming that everybody knows how to plot a point. If I ask you to plot the point 2, 3, you should go over 2 and up 3, because 2 represents the change in x, and 3 represents the change in y from your origin. So I'm assuming that you can plot points. If you're having trouble with that, page 107 gives information about plotting coordinates. I'm not going to go over that, okay? I'm making that assumption. Second, let's take a look at this equation and graph it just by plotting points. Not using slope, not using anything else that we've learned already, maybe you've seen before. Just plotting points. Okay, so let's take a look. Pick some points for x. What points for x might I want to choose? Okay, what else? What else? 3. Another point for x that's very easy to always use? 2. 2 is also easy, but one that's easier than 2? 0. And then maybe what else? Maybe some negatives, right? Yeah, so like -1, -2. So let's do this. Let's go from -1 to 3. Okay? So generally when you're graphing lines and you're going to graph by plotting points, but you really aren't going to do much of this at all. We're just going to talk about it for a little while. But traditionally you're going to graph with slope and y-intercept and intercept, x-intercept and y-intercept. You're not really going to graph by plotting points.
Don't we have to do 2?
Absolutely. Absolutely. And that's what we're going to talk about. Yep. You're 100% right. The reason I'm doing 5 for now is just to prove that if we graph between 2 of those points and then another 2 and then another 2, those will all become concurrent lines. And they'll sit on top of each other. Okay? What do I want to do to make this easy on myself? I don't want to plug in x 5 times and solve every single time. I should. Yeah, find the generic solution. So simply subtract the 2x from both sides. Okay, giving us 7 minus 2x. Many of you know already that -2 is the slope now, and 7 is the y-intercept, and that's good, because you've seen that before, but we're going to talk about that in the next section. For today, let's simply look at just graphing by points. So plugging in points. Can somebody either give me their table and run off the numbers, or just go right through them?
-1 is 9, 0 is 7, 1 is 5, 2 I'm assuming is 3, and 3 is 1.
Good. So Georgia picked up on the pattern. That's why she used the word assume there. Take a look. We're going down in the y direction by how much?
2.
And hey, take a look at the slope. What is it? -2. That only works because we're going up in the x direction by a constant of 1. Okay? So be careful. If you went up in the x direction by 2's, these would go down by 4's. Okay? It would go up proportionally. So be careful with that. Now, we've got 5 points. We can plot them all. But as Hannah said a moment ago, you only need to plot 2 of them. You only ever need to plot 2 points. Why is that? Why is that? Why do I only need 2 points? But what about all those other points that are on the line? Don't those help me?
Yeah, but those just make it easier to trace them.
Yeah, they just make it easier. What does the first point give me? It gives me a point in space, right? What does the second point give me?
The slope.
The slope or the direction it's going. So if I know 1 point, I literally have a point in space. My fist right here on the board. But I need another point. Watch, here's the other point. Now what kind of a slope is it? It's falling, so it's... Okay, we'll get to this in the next section, but negative. The slope would be negative for these two. But if I suddenly move the second point down to here, now the slope is going to be... So this second point is what's dictating the pitch, or the angle of the line. Okay? The angle, the slope, the pitch, all those words are the same, really. Okay? The rate at which the line is changing. Pitch in music, what does that mean? Pitch. Yeah, the key, okay, kind of. Kind of. What is pitch directly related to, though? The what of the sound? Good. The frequency, whether it's high or low. And frequency is a measurement of a rate. Okay, it's a sound rate. So frequency, for example, is 1 over seconds. That's the units. The idea is that it's changing over time, the pitch. Okay? So for this one, if we were to graph 2 points, which 2 points would be the easiest to graph here? Because you don't need all 5, clearly. Which 2?
0, 7.
0, 7, absolutely. I agree totally. Whenever you have an intercept, graph that to start. Is that clear? I know it sounds ridiculous, but it really does make it easier. So go 0 in the x direction and go up 7 in the y direction. Many of you know that there's a graph paper background on Notability. This might be one of those times where you change that setting on the notes. I don't know how it works exactly, or can you drop a graph on there?
Oh, yeah.
It's not working because let me see real quick. You know why? It's because it's a PDF format on top of it. It's an image on top. Is there a way you can insert an image of a graph?
Oh, yeah.
Or you could do this. I have an idea. You could somehow take a picture or screenshot of a graph and save that as an image of graph paper and just insert an image every time. Or just you can Google graph paper, search under the images on graph paper, save one of the graph papers that works well for you. Go ahead and save that onto your camera roll. And then every time you want to graph something on Notability, just press the plus sign and insert an image and find that image on your camera roll. So if you tap it, you can probably save it to your camera roll.
Look at that beautiful piece of
Can you tap and hold it?
This one.
Yeah, use one that already has an XY axis, guys.
Look at this, Mr. Howard.
The one that you had is the best. That one, that's the one you want to use.
This is genius.
That's it. Go back.
Look at this one.
Next thing you know, he's going to be creating this.
Here.
Alright.
Okay. Tori May, can you share that with other people somehow? Is there a way to send that out? She's got a good image. Which one do you have? Yeah, that's the same image. Good.
Oh, I have the same image that's not necessary. Oh, wait, airdrop.
Guys, go on. What is this called? Airdrop? Yeah, perfect. Good. So, guys, get one like this, please. Tori May's sending hers out on airdrop if you need it. So try and get a graph that looks like this, where you have an axis on it already. Okay? If you need help saving the image to your camera roll, let me know.
Accept. Got it.
What about Christian?
And then, yep, you're going to go to there. And then
No, who's Richard?
How you doing?
Oh no.
All right, so you want just the image though, right? So can we go back to where that was? Double click your, okay. So you just want to view image. Hit view image. Okay, so yeah, let's go back to the browser. Hit view image.
Got it.
And well, you want the one with the graph, the axis on it. So let's take a look.
I don't know. Because it's not.
Let's find this one here.
No, apologize right now.
Hold it. Okay. Save image.
It's fine. I was just out of
Okay, now go back to your app. Go back to Notability.
No.
Get rid of this. Done or delete. Delete it.
Can you stop grabbing?
Get rid of that one. Okay, insert a new image from your plus sign. Go to your camera roll. Is that cool? You got it? All right, nice. No problem. Does anybody need help real quick? And please raise your hand if you do. It's not a big deal.
I don't know why it keeps stabbing every time I try to draw. Richard's eye.
You have to get
Why is it so funny?
Christian, you want it?
Oh,
I said,
good?
anyone else?
Yeah, good. Oh, you got one with numbers on it. I either downloaded one with numbers on it. Now, be careful. You should also get one without numbers on it because you're not always going to use 1, 2, 3, 4. In this class, you're going to see a lot of graphing like 3, 6, 9, 12. Okay? All right. Let's get back to this now. Guys, that was good. I'm glad you're using this to your advantage. I'm also going to... Thank you. I'm also going to graph the point 3, 1, because to me that seems like an easier point. So I go over 3 and I go up 1, and I connect these two lines, or these two dots. Guys, up here, let's end the discussion for now. Thank you. So we have the 2 points, 0, 7 and 3, 1. Okay, those are our 2 points. If we plotted any other point in this table, it will fall on that line, right? That's the idea. The table is a solution of points that fit on the line. So if you pick any point in this table right now, 2 comma 3. Go over 2, go up 1, 2, 3. Boom, it's right there on the line. Okay? So every time you do this, you're going to end up on the line. There's 2 comma 3. So the idea by graphing by points is that you just have to graph 2 points. Now, personally, it's a bit tedious to do that every time. And you want to know what slope is, because slope has a meaning to it, has a rate of change, and we'll talk about that. So for now, you understand how to do this. You're not really going to be graphing this way. Is that clear? But you see where the graph comes from? Okay, a solution of points. Let's go. Next, we're going to graph using intercepts. Okay, using intercepts. Well, we already did the y-intercept, didn't we? We did that a moment ago. The y-intercept in the last example was 0, 7. When you have a y-intercept, what was the x-coordinate? What did I just say? What was the x-coordinate of the y-intercept for the last graph we just did? 0, right? It was 0, 7. So when you want to find the y-intercept, you should set x equal to. But when you want to find the x-intercept, what should you do? Okay? So that's all this paragraph says right here. Let's go ahead and do that. You do not need to solve for y here. Please don't solve for y or solve for x. This is the one time you're not going to come up with a generic solution. Find the y-intercept by setting x equal to 0 and solve for y. Okay, so do it. So again, this is to find the y-intercept. We set x equal to 0, which drops off, and then just divide by -3. So what's the y-intercept? That's the value of the y-intercept. What is the y-intercept? 0, 3. Please be careful, okay? A lot of people say 3 is the y-intercept. Sure, it's okay, but that's the value of the y-intercept. The coordinate is indeed 0, 3. Find the x-intercept, go.
Oh my god. This is my favorite part of that.
Yeah, this is
Because I learned it last year and actually.
I like to be.
Yeah, and this is something that is definitely useful. Okay, you're going to use lines a lot. We're going to talk about a lot of application problems that are useful for everyday life. Simple things, like traveling on a subway system. Well, not New York is the exception, but anywhere else. It's a function of the distance you travel, right? As you travel further, it costs more money. That's a slope. It's a rate of charge. A cab, 10 cents, or not 10 cents anymore. What is it, 50 cents every 10th of a mile? That's a rate. That's a slope. Whatever it is. Solve. Guys, if you're graphing by intercepts, you need both intercepts so that you have 2 points. Is it negative? Yeah, I forgot my negative sign. Okay, so please go ahead and check your answer. Make sure you got the same thing. Remember, don't forget the 0 for the y when you're solving for the x-intercept as a coordinate. It is indeed a coordinate. Graph those 2 intercepts on your graph and just connect them and you're done with this graph. This graph is cake. Easy.
Oh, do we say graph?
I think,
Girl?
yeah, the directions, yeah girl, the directions say, graph by the y-intercept. Graph by intercepts.
Alright, right there.
I thought we already had the. Oh, man.
You guys are funny.
Oh, man.
Okay? So plot your 2 points. Don't forget to label your axes. And please also label the increments, but just put them somewhere. So I would do this. I would put a 1 here and a 1 here, so that Mr. Howe knows that you're going up by 1s on the x and y axis. I am in the third person now too. It's crazy today. You can go by different increments. You can make the x-axis go by 2s and the y-axis go by 5s, but you need to be consistent within that axis. Okay? So you can't go like 1, 2, 7, 9, 12. You need to be consistent on that axis. There is something called a jump or a break you can put in the graph, and I'll talk about that.
Isn't that little line?
It's a little squiggly line. It means like skip a bunch of data and start at like 2000.
Like if you're starting at like graph.
Exactly. Yep. Next.
Oh, that's in your video. Oh, wait, you recorded your now we're gonna
Yeah. Whatever. Next. I didn't think about that.
He said, yeah, girl.
We have to watch a video and record it and remember forever.
All right. Anyway, that was.
It's
I
really
didn't
hard to
think
get a
of
straight line. Is there like a line insert that you can just pop in there?
it. Okay. There.
Red clips?
No.
Figures.
But the problem with the figure is that you can make a line, but then you can't change the. Like here's the line tool right here, and you can put a line on here, but then you can't change the angle of it afterwards. You have to get it perfect. So where is it? Get it up there. It is. So you can make a line, okay? But you have to come up with the right angle. Then it's done, and then it takes that line and then it lays it on top. So it's not going to work right now.
That's it.
You know what I've done, guys? Here's what I've done. You know your ID card? Did you get your ID cards yet for school?
Yes.
They're plastic, aren't they? The plastic ID cards? Okay, take them and put them up against your iPad screen and use those as a straight edge if you need to make a straight line. It's worked pretty well for me with physics so far. See how it works for you? No? Take your ID card, flatten it against your iPad screen, and use it as a straight edge.
You understand these marvelous ideas today.
I just thought of it when I was like trying to figure it out for physics. I could not graph. It wouldn't work, anything, so.
It's not working.
It's not working for you?
No, it keeps like zooming in.
Oh no, guys, listen. Folks, look up, please, look up. Take it. I know, I'm sorry. Take it and go like this, at an angle. Don't put it flat. Hold it at an angle and try it. Turn it out with your fingers. See the difference? If you push flat, the electrons or the electrical charge in your finger goes through the card into the board, into the tablet, which makes it feel like there's two fingers on it, which is why it was zooming for you. Okay? So you need to hold it at like an angle. Okay, hold it at an angle to your page.
Oh my God, you can write with this.
Yeah.
I'm sorry, I'm a bit.
Because if your finger, is the impulse that's coming through is going through the card. Okay? All right, back up to the board now. Here we go. We need to focus, guys. We need to focus now. Graph the following on a coordinate plane. Now, at first it looks like what is going on? These aren't equations, right? But the first one is really this, and this is what you have to think about. Okay, and I know it's weird. Think about this, please. That's what this is. And this one is really this. So far, does that make sense what I did? Just think about it in AX plus BY equals C form, which we'll talk about that next class. But the idea is that it's X and Y and some number. X and Y and some number. If you don't have X or if you don't have Y, it's really a zero there. Now, if you plug in any number for X, Aida, pick a number for the first one, any number. Plug it in for X, what does Y become? Because 2 times 0 is 0, right? Pick another number, Tori May, instead of 2 for X.
11.
11 times 0 is what?
0.
So what's Y?
5.
It's still 5. So no matter what you put in for X in the first one, so let's do part A first. In our table for X, no matter what number we put in, what is Y always? It's always 5. Y is always going to be 5. Plug in any number for X, it's always going to be 5.
These are like when you get
Oh,
like
it's
the
a
straight line.
That's what Y equals 5 means. Y equals 5 means that it's always going to be 5 for the Y coordinate. So make a bunch of coordinates. 2, 5, 7, 5, 11, 5. Anything with a 5 in the Y is going to end up being a horizontal line. Graph these 3 points on an axis. You're going to graph 3 points. They're going to be at the same height.
You graph a lot.
Okay, it's going to be 2, comma 5. 7, comma 5. 11, comma 5. What do you notice? The points are all at the same height. So it's a horizontal line.
Oh, wait, I didn't.
It's hard to do.
Any questions on part A? On part A? Please ask.
And this is what I'm supposed to do.
Yep. Now, write this down, please, everybody. Please write this down. Y equals K. Y equals K is the generic form for a horizontal line. where k is some number. Where k, so y equals k is the generic form of a horizontal line. Y equals k is the generic form of a horizontal line where k is some quantity or number that represents the height of the line. Notice, where's the height of this line? At 5, because it was y equals 5. Does that make sense? Now, because you guys are so intuitive and can think outside the box, what can we say about part B? What can we say about part B?
X equals k.
Or h, we'll say. It's a different variable. X equals h.
X equals h is the generic form of a vertical line.
Of a vertical line. Very good. A vertical line where h represents what? Yeah. Location or whatever, okay? So the part B is going to be a vertical line now. And you can prove that by doing the same thing we just did. But part B will be a vertical line going through negative 3.5 on the x-axis. I'll do it on the board real quick.
Wait, and then that's representing the
And k represents the height of the function. This represents, you could say, the width or the location. Either word is acceptable.
Wait, so it would be x equals h is the generic form for a vertical line.
Exactly. X equals h.
The number of
The number that represents the width of the function or the location of it.
So 7.7 is negative 3.
So here's what I do. Take a look at the board. I go over 3.5 units to the left. I simply put one dot there, and then I make a vertical line. You can make that dot in another spot also, please, if it helps you to make a vertical line. Clearly, I can't make a vertical line. I have an eraser.
Our eraser is different.
Yeah.
I think.
It's a different app. It runs differently. So this is a vertical line, and this represents x equals negative 3.5. Well, negative 3.5 is the location of where it intersects the x-axis. Okay? We need to do one more example. One more example. Does this make sense? So x equals is a vertical line. Y equals is a horizontal line. When in doubt, here's your trick. Ready? When in doubt, if you forget, go to your graphing calculator real quick. In y1, just type in a number. Type in the number like 7 and see what you see on your graphing calculator. And that'll remind you as to what the forms are. Just type in a number for y1, a number less than 10 preferably, so you can see it on your graphing calculator. Okay, go to y1 and just type in y equals and pick a number less than 10. And you'll see it appear on your graph. So you remember that y equals is a horizontal line. If you ever forget, you can always check. So type in any number below the 10. 3, 4, 5, 2. Perfect. Graph. Oh, zoom 6 real quick so we can see this a little better. And there it is. So that reminds you that y equals some number is a horizontal line. So if you ever forget on your test, now you can remember, oh, x equals some number must be the vertical line. Okay? All right, next example. Find the value of k. Folks, up here, back to the board. Find the value of k so that the point P lies on the line L. Find the value of k so that the point P lies on the line L. What does a point do? A point is blank of the equation. A point is the blank of the equation. Yes, but hold on one sec, Francis. A point is the blank of the equation. Fill in the blank. What's the word you're missing here? The what? I heard something. It sounded like it was right. Okay. I heard something else.
I said something.
What does it start with?
You're finding out what x and y are, so you're finding the blank of the equation. Yeah, the point is the solution to the equation. Write that down. The point is really a solution to the equation. The point is a solution to the equation. It's so important that that's understood. Whenever you're finding points in your table, those are just solutions to the equation. That's why they lie on the line. So if that's a solution to the equation, as Francis said a moment ago, please just plug it in. Please just plug it in. Okay? Go ahead and take a moment and plug in the point and figure out what K is on your own. Question or answer?
Would this solve generically for K?
You don't. You could if you want to, but it might be more work. It might be more difficult to solve generically for K. So just go ahead and plug in.
Okay, there's no need to say that.
Work on it on your own, please.
You need to graph it.
No graphing involved, guys.
Got it. I know what it is.
Please keep working. Don't look up if you're not done. Keep working. Keep working.
What was actually really hard?
Did everybody get 2 for K?
Full circle, right?
Okay? 2. So the line would be... Guys, stop. Come on, we're running out of time. The line would be 4x minus 2y equals negative 2. That's what the line really is, because we found the value of K. So if we wanted to write out what the line is, that's what it would be. Let's quickly look at the last one. And the last one's a very quick. Graph the 2 lines on the same solution, or same set of axes, and find the coordinates. Then show that this is a solution to both equations. Okay?
So find like where they meet.
So you can either go ahead and look at your calculator right now and try this, or graph it on your graph on your paper and find their intersection. Okay, here's what it's going to generically look like, because you're going to run out of time. Here, look. Real quick. Here's what it's going to look like. The solution here should be at negative 1, comma 2. And when you find that solution of that intersection, if you plug in that point, it'll satisfy both equations. That's the interesting part. Okay? If you need help on this, I'm going to record the video today. Look at this last example tonight. Make sure you do your homework over the weekend, guys. Work on your problem sets, please. You should have everything through 3-2 done by this weekend on problem sets. The test is not for like another week, but I'm telling you, next week's going to be a lot tougher than this is. So get everything done on your problem sets this weekend if you can. I won't give you all the other homework for that reason.